Imagine a ship so vast it dwarfs the Eiffel Tower. A vessel that could carry 4.1 million barrels of oil, yet struggled to navigate the world's major canals. This is the story of the Seawise Giant, once the longest ship ever built, and an epic tale of engineering ambition, disaster, and rebirth. In 1979, Sumitomo Heavy Industries in Japan completed a ship that would go on to push the boundaries of maritime engineering. Built at Opama Shipyard in Yokosuka, Japan, to be an ultra-large crude carrier, the vessel, originally named Opama, measured an impressive 378.9 meters, or 1,243 feet in length. However, the construction process saw its share of challenges. As the Giant took shape, the world was changing. The 1973 oil crisis sent shockwaves through the global economy. Suddenly, the economics of supersized oil tankers seemed less certain. By 1979, when construction was nearly complete, the original buyer backed out, leaving the world's largest ship without an owner. Enter C.Y. Tung, a visionary in maritime commerce. C.Y. Tung was no ordinary shipping magnate. Born in 1912, he built his maritime empire from a single second-hand ship in the 1940s to a fleet of over 150 vessels in the 1970s. Tung was known for his bold vision and willingness to take calculated risks. His company, Orient Overseas Container Line, pioneered container shipping in Asia. Tung had a keen eye for opportunity and a deep understanding of global trade trends. He firmly believed in the concept of economies of scale in shipping, often saying, "The bigger the ship, the bigger the profit." Where others saw risk, Tung saw opportunity. He understood that despite short-term volatility, the future of global trade would require ever larger ships. In 1981, Tung purchased the ship and renamed it Seawise Giant. But he wasn't content with its current size. C.Y. Tung saw untapped potential in the already massive vessel. Under Tung's direction, the ship underwent a remarkable transformation. It was expanded to an astonishing 458.45 meters, or 1,504 feet in length, with a deadweight tonnage of 564,763 tons. This made Seawise Giant not just the longest ship in the world, but also the heaviest self-propelled object ever built. The Seawise Giant wasn't just big. It was a masterclass in scaled-up naval architecture. The challenges faced by engineers were immense. At over 1,500 feet long, the ship would naturally twist and bend under its own weight and the relentless forces of the sea. To combat these forces, engineers turned to high-tensile steel, specifically Grade A steel with a yield strength of 355 megapascals. To put this in perspective, this steel is about 3 times stronger than the steel used in typical building construction. It can withstand stress equivalent to the weight of 36 large elephants pressed down on every square inch. This material choice was crucial. It allowed for a lighter overall structure while maintaining the strength needed to withstand the enormous stresses of its size. But material alone wasn't enough. The ship's skeleton consisted of an intricate framework of longitudinal and transverse bulkheads, creating a grid-like internal structure. This innovative design distributed stress more evenly along the hull, preventing localized weak points and reducing the risk of structural failure. The result was a marvel of engineering, a ship that could flex without breaking, withstanding the harshest conditions the open ocean could throw at it. Powering this Leviathan was no small feat. The main engine room housed a marvel of engineering, a Hyundai-built Sulzer 12 RTA 96C two-stroke diesel engine. This behemoth produced 50,000 horsepower, or 37,285 kilowatts. To put that in perspective, that's equivalent to the power of 500 family cars. The engine drove a single propeller measuring 30 feet in diameter and weighing 50 tons. Navigation of such a massive vessel required equally impressive technology. The bridge stretched 98 feet across, wider than many ships are long. It housed state-of-the-art navigation systems for its time, including early GPS technology, radar systems, and computerized charts. But perhaps most crucial was the ballast control room. Here, operators managed the complex task of balancing the ship as its cargo was loaded and unloaded. To truly appreciate the Seawise Giant, we need to understand its place in the evolution of ship design. In the 1970s, most supertankers, like the Battleless class, maxed out at around 550,000 deadweight tons. The Seawise Giant blew past this limit, reaching 564,763 deadweight tons after its expansion. This leap in size required rethinking many aspects of ship design. For instance, the hull had to be strengthened to prevent hogging and sagging, the tendency of a ship to bend along its length due to uneven buoyancy forces. The Seawise Giant's influence on future ship designs was significant. While few ships approached its overall size, many of its innovations were adopted in the next generation of ultra-large crude carriers. For example, the double hull design, which became standard in the 1990s, was partly influenced by the structural lessons learned from ships like the Seawise Giant. Operating the Seawise Giant was a constant exercise in precision and planning. Its massive draft of 81 feet meant it could navigate in the deepest waters. This restricted its routes and the ports it could access. Loading and unloading presented another set of challenges. The process could take up to 48 hours, transferring oil at a rate of 85,000 barrels per hour. Crew life on board was unique. With a length greater than many cruise ships, simply walking from one end to the other could take up to 30 minutes, considering obstacles and layout, safety considerations, work-related stops, environmental conditions, personal equipment. The ship's enormous size also made it vulnerable to extreme weather. In high seas, the bow and stern could move independently, creating torsonial stresses that required constant monitoring. The Seawise Giant wasn't just an engineering marvel, it was a game-changer in the global oil trade. Its massive capacity, over 4 million barrels, allowed for economies of scale previously unseen in oil shipping. In a single voyage, it could transport enough oil to meet the daily consumption needs of a country like France for nearly 2 weeks. However, the economics of such large ships were complex. While they offered unparalleled capacity, they also came with higher operational costs and limited flexibility. The Seawise Giant's story paralleled the boom and bust cycles of the global oil market, reflecting the industry's constant balance between capacity and demand. In 1988, disaster struck. Caught in the crossfire of the Iran-Iraq War, the Seawise Giant was hit by Iraqi missiles. The damage was catastrophic. Fires raged across the deck and in the surrounding waters. Declared a total loss, it seemed the end for the world's largest ship. But the Seawise Giant's story wasn't over. In a feat of engineering audacity, a Norwegian company, Normand International, decided to salvage the Giant. The operation, managed by Normand International, involved replacing 3,700 tons of steel, equivalent to half the weight of the Eiffel Tower. Reborn as the Happy Giant, the ship returned to service in 1991. Over the next decade, it would change hands and names several times. Originally built as Opama, it became Seawise Giant under C.Y. Tung's ownership. After its repair, it was renamed Happy Giant, then Yare Viking under Norwegian ownership. In 2004, the ship, now called Nok Nevis, faced a new challenge. Engineers were tasked with converting this massive oil tanker into a stationary floating storage and offloading unit. This involved removing many of its cargo tanks and installing new systems for long-term stationary operation. In its final years, it was briefly renamed Mont before being decommissioned. The influence of the Seawise Giant continues to ripple through the maritime industry today, inspiring even larger structures. Lessons learned from the Giant's operation led to advancements in maritime safety regulations, particularly in areas of structural design and emergency response protocols. Today, while no oil tankers match the Seawise Giant's size, its legacy lives on in even larger maritime structures. In 2013, Shell's Prelude FLNG facility became the world's longest floating structure at 488 meters, surpassing the Seawise Giant's 458.45 meters. Today, while no oil tankers match the Seawise Giant's size, its legacy lives on in modern megaships like container vessels and floating production storage and offloading units. However, the Seawise Giant remains unmatched as a mobile vessel. The Prelude, designed as a stationary natural gas processing facility, builds upon the engineering feats achieved by the Giant. The challenge of building bigger while maintaining efficiency and safety continues to drive innovation in naval architecture and marine engineering, from massive container ships like the Ever Ace to floating production storage and offloading units like the Egina. As we look to the future, the spirit of innovation embodied by the Seawise Giant continues to inspire new generations of maritime engineers. In 2009, the Seawise Giant made its final voyage to a ship-breaking yard in Alang, India. As impressive as the Sea Giant was, it also highlighted the environmental challenges of massive ships. Today, the maritime industry is using lessons from the Seawise Giant to build more efficient and environmentally friendly vessels. The Seawise Giant was more than just a ship. It was a floating testament to human ingenuity, a challenge to the limits of marine engineering, and a harbinger of the future of global trade. Its legacy lives on in every ultra-large vessel that sails the seas today, a reminder that with vision, skill, and perseverance, we can build the impossible.
Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.